Hi everyone, today we're doing lesson 5.2b, so our second day of this. We're doing more direct variation. Our objectives today are to recognize a directly proportional relationship, write a direct variation equation in the form y equals kx, and graph a direct variation equation. Let's do a quick review. Remember, we can find direct variation from a table. If we look straight across the table, we should be able to determine what you multiply x by to get y. The 0 is not real helpful because that could be any number. You multiply 0 by any number to get 0. But 1 times 3 will get you 3. 2 times 3 will get you 6. 3 times 3 will get you 9. You can also look at your y over x patterns. They will be proportionate, which means they're going to be equal fractions. 3 over 1, 6 over 2, 9 over 3. Those are all equivalent fractions. So this is proportional, and they all equal 3. When we write our equation then, we put y equals, put our y over x pattern, in this case 3x. And then when you graph it, it will be linear and it will always go through the origin 0, 0. So here we're going to show some similarities and differences between direct variations and not direct variations. If I look across this table, I should be able to see what am I multiplying x by to get to y. And in each one of these, I am multiplying by -4. And I could see that because this is -4 over 1, -8 over 2. Those are all equal to -4. So that is my slope, or my k in this equation, and x. Okay, let's look across here. Again, I have a pattern. You might want to say it is divide by 2, which it is, but since we're looking for multiplication pattern, what am I multiplying to get from x to y? Get from x to y, from 10 to 5, or in other words, my y over x, 5 over 10, 4 over 8, 3 over 6. That is all equivalent to 1/2. So y equals 1/2 x. Now let's compare that to one here that's not a direct variation. Here I cannot look across the table. I can go from here to here and see that I am adding 3 each time. So this is a linear equation, but it is not a direct variation. And you can see that because I do not have that constant. 7 over 1 is not the same as 10 over 2. Because this would be 7, this would be 5. So in this case, it's going to be y equals 3x, because my change in y, which is 3, over my change in x, which is 1, is 3. Now, if you looked over here, my change in y is -4, over my change in x is 1. So I can still get that slope value by looking at my change in y over change in x. I still get -4. In this case, it's 3. But I'm going to have to add or subtract something here in order to finish this equation. I would need to back up my table to the 0 value and say what number would be here. Well, this would be 4, because 4 plus 3 will get me to that 7. So my equation here is 3x plus 4. Okay, let's look at this. My y over x, this would be -2 over 8. That is 1/4. I have -1 over 6. That's -1/6. Those are not the same, so this is not a direct variation. I can tell that right away. So I can't look across the table, but let's see if we have a constant change in y over change in x pattern. This is adding 1. This is adding 1. And this is adding 1. while on the other side, I'm subtracting 2 every single time. So I do have a constant pattern. This is a linear equation, but it is not a direct variation. So what is my slope? Well, this is going to be 1 over negative 2, which is the same as negative 1/2. And I need to know my 0 value. If I brought this to 0 by subtracting 2 more, I would add 1 more over here, and that would be 2. So it would be negative 1/2 x plus 2. Oh, I was writing 4. It's a 2 plus 2. So they both have a slope attached to the x, but if you don't have a direct variation, these are both linear. If you don't have a direct variation, you're going to be adding or subtracting something at the end. If you have a direct variation, it's just y equals kx, the slope times x. Oops, went too far. Okay, let's look across the table here and decide which one of these isn't a direct variation. If I go from x to y, am I multiplying by the same thing? Well, negative 2 times 4 is negative 8. Negative 1 times 4 is negative 4. 0 times 4 is 0. 1 times 4 is 4. So this would be y equals 4x, and that is a direct variation. Let's look at b. Well, from 0 to 0, can't tell what that is yet. From 3 to 1/3, I am multiplying by, 3 to 1, sorry. I am multiplying by 1/3. 6 to 2, I'm multiplying by 1/3. 9 to 3, I'm multiplying by 1/3. I could also do my y over x pattern. This is 3 over 9, which equals 1/3. This is 2 over 6, also equal to 1/3. So I have equivalent fractions. This is proportional, therefore it is a direct variation. My equation would be y equals 1/3 x. How about this one? How do I get from 1 to 5? Looks like I'm multiplying by 5. Is that true for all of them? Yep, 3 times 5 is 15. 4 times 5 is 20. If I made my y over x, I'd have 5 over 1, 10 over 2, 15 over 3, 20 over 4. All of those are equal to 5. So this is y equals 5x. That is a direct variation. So I can write in y equals kx form. Okay, let's look at the next one. 1 to 1, I'm multiplying by 1. 2 to 2, I'm multiplying by 2. 3 to 3, multiplying by 3. 4 to 4, 16. What am I saying? 4 to 4. 4 to 16, multiplying by 4. So 1 over 1 is not the same as 4 over 2. That is not the same as 9 over 3 or 16 over 4. But you probably did notice something. This is not a direct variation, so this is our answer. You may have noticed that my equation for this is y equals x to the second power. Because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, but not a direct variation. I didn't clear my screen. Okay, each one of these shows a direct variation, so they're telling us that it's a direct variation. We just need to figure out what our k is. So how did I get from 8 to 24, 5 to negative 15, 3 to negative 9? You're right, I'm multiplying by negative 3. So y equals negative 3x. How about from 12 to 6, 14 to 7, 16 to 8? If you sometimes have trouble seeing them, write the y over x, 6 over 12. You can simplify that to 1/2. 7 over 14, I can simplify to 1/2. This is 1/2 x. How about this one? This one might be a little trickier. I have 14 over 21. 6 over 9. And 8 over 12. And all of those can be simplified. Let's start at the bottom. What goes into both 8 and 12? Well, 4 does. So I'm going to divide them both by 4, and I get 2/3. 6 and 9, I can divide by 3. I get 2/3. 14 and 21, I can divide by 7, and I get 2/3. So there's my k. It is 2/3. Y equals 2/3 x. If I take x and multiply by 2/3, I will get y. And here again, I could write it as in fraction form and check it out. 4 over negative 12, 2 over negative 6, and 6 over negative 18. Whenever you see the one negative, just bring it out in front. That makes it easier. So it's going to be a negative number because I have a positive and a negative, so it will be negative. And each one of these will simplify to 1/3. So y equals negative 1/3 x. Okay, so let's say, suppose the cost of buying a shirt varies directly. That means we're going to have a y equals kx with the number of t-shirts you buy. It costs $91.50 to buy 6 t-shirts. So, how can we figure out my variation? Well, one of my y's is 91.50. One of my x's is 6. It tells us it's a direct variation, so I can just know that. It is 91.50, my y, over x, which is 6. I am going to simplify that to a 1. It is a decimal. However, because we're talking money, I usually do simplify that to find out the cost of one shirt. So 91.50 divided by 6 will give me $15.25 for each shirt. So my equation will be total cost, y, will equal $15.25 for every t-shirt. Now that we know that, we can find the cost for buying 9 t-shirts. We're just going to substitute 9 for x, 15.25, times 9. 1525 times 9. I'm grabbing my calculator for that. I have $137.25. So the cost of buying 9 shirts will be $137. Lost my pen there for a minute. $137.25. I think that's what I said. Okay, we're going to graph some direct variation equations. Y equals 2/3 x. We know that each one of these will start at 0, 0. We're going to have a point at 0, 0. They all go through 0, 0. This is a positive slope. So I'm going to have a rise of 1, 2, and a run of 1, 2, 3. That is my slope. Rise of 1, 2, run of 1, 2, 3. It'll go over there somewhere. Now, I could make them both negative. I could go down 1, 2, and left 1, 2, 3, because we know a negative over a negative is a positive. And I can continue drawing my lines. Very easy, right? You don't even need to come up with points. You just graph your using your slope. I'm going to put the other points in here so I have them. Okay, y equals 4x. Well, again, I'm going to start at 0, 0. It's a positive slope, so I know it'll be going uphill. 4 is same as 4 over 1. So I'm going to rise 1, 2, 3, 4, and run 1. Or I could go down 1, 2, 3, 4, and run 1 to the left. Because negative over negative. You can then see from this point to 0, 0, I'm rising 4, running 1. Then connect your points. Hopefully I can draw a relatively straight line. It's a little bit wonky, but it's hard to do that with my little mouse. I should go through this point. Kind of missed it a bit. Arrows on both ends because it goes on forever. Y equals 4x. Next one, negative 3/4 y. X. So again, I'm going to start at 0, 0. I can run up 3, 1, 2, 3, and left 1, 2, 3, 4 to get that negative 4. Or I could go down 1, 2, 3 for my negative 3 and make it a positive 4. As long as 1 is positive, 1 is negative, you will get your nice negative slope here. Oh, I was doing so well, and then I got a little bump there. And that will be my graph of negative 3/4. Again, for negative 5 over 1, it's going to start at 0, 0. I can rise 5 and run 1 to the left, make it a negative 1. Or I can rise negative 5 or go down and run 1 to the right. And connect my points somewhat. It's such a long draw. If I come close, I'm surprised. So that would be my negative 5x. That's it. Have a great day.